So square the first, square the last for the outside two of the trinomial, and for the middle term, you multiply them both together. Okay? Now, what are the signs that go with this? The binomial is the same as the problem. The next term is the opposite of that, and the last term, always positive. Okay? Always positive. Now, the good part about this is that if I say, can you factor this one? What if I ask you to factor 8a cubed minus 1, plus 1? Can you factor that? What is it? This one was the difference of cubes. This is the sum of cubes, right? Okay? If you know the pattern, I didn't ever make you memorize a formula, right? I taught you a pattern. If you know this pattern, then you know how to factor this one. Up here, difference of squares, we could factor. Sum of squares, we could not. It was prime. You can factor both the difference of cubes and the sum of cubes. Okay? But the deal is it's the same pattern. A binomial and a trinomial. The cube root of the first one goes at the beginning of the binomial. The cube root of the last one goes at the end of the binomial. The pattern for the trinomial is the same as over here. Square the first one, 4a squared, multiply them together, 2a, square the last one. And the sign pattern is the same. Okay? Whatever was in the problem is in the binomial. The next one is opposite of that, and the last one, correct, always positive. Does that make sense? Okay, now, are those the only ways we can factor or solve by factoring? So no, right? But those are the most common ways that we solve by factoring. We didn't factor by grouping, but we kind of did, because we did like a four term right here where we factor the first two and the last two. So I didn't do a specific example I called factoring by grouping. That was kind of involved in this one right here. Okay, I'm going to go ahead and write difference of cubes and sum of cubes. So you have the name written down. Okay, difference of cubes and sum of cubes. So the second objective that we need to talk about is solving quadratics by completing the square root property. Okay. And that's typically easier than like a really easy thing, because if we're solving by square root properties, what we have is something like this: 3x squared minus 15 equals 0. There's no x term. I'm not having to figuring out what multiplies to be the last and adds to be the middle, because there's no middle. There's no x term. So typically when we're solving by square root property, we just want to get all the variables on one side and all the constants on the other. So I want to add 15 to both sides, just like solving a basic equation. 3x squared equals 15. Divide both sides by 3 to get the variable isolated. So I have x squared equals 5. And then to solve for x, I have to square root both sides. The only thing that you forget, that almost everyone forgets, is the fundamental theorem of algebra. Fundamental theorem of algebra says whatever the highest exponent is, that's the most solutions you're going to have, and most often that's how many solutions you will have. Okay? So how many solutions should we get? 2. And if all I do is write down the square root of 5, that's only one solution. You have to remember, because what it's saying is, like, it's easier to talk about if we say 9, right? What's the square root of 9? 3. Because everyone believes that 3 times 3 is 9. Well, you believe that because it's true, right? But is there anything else that multiplies by itself that gives you 9? -3. Yeah, absolutely. Okay, so when we take the square root of both sides, we have to take into account both the positive and the negative of whatever number I get, because those are my two solutions. Okay, that's what a lot of people forget. I'm not mad, I just help you remember. Okay, so another example would be if I started something like this. Now, we have a couple options here, right? We could go ahead and square this. And if I squared it, I'd get an x squared term and an x term and a constant and this other constant over here, which I'd have to move over here to get it to equal 0. That's messy, but this is already something squared. So couldn't I just take the square root of that? If I take the square root of something being squared, I just get that thing, right? Equals what? Plus or minus the square root of 6. So when I go to solve for x by adding 2 to both sides, I still get two answers. I get 2 plus the square root of 6 and 2 minus the square root of 6. Okay? Any questions about that? So that is square root property. So the third one, solve quadratic equations by completing the square. Okay? This is one of my favorite because to me it's a puzzle. I'm just trying to figure out what the missing number is to make everything work nice. That's why I like completing the square stuff. Okay? So before we actually get into solving equations by completing the square, let's remember how to complete the square. Okay? So if I give you something like x squared plus 8x, I need you to complete the square. So the way we do that is we look at this middle term, this x term, and I divide it by 2, and I square it. What is 8 divided by 2? And what's 4 squared? So guess what goes in the blank? 16. What if it was, excuse me, x squared minus 10x? So divide it by 2 and square it gives me 25. Is it plus 25 or minus 25? This is negative 10. Oh, because I squared it, right? Negative 5 times negative 5. So am I ever going to subtract anything right here if I'm completing the square? No, always add, okay? And then what about this one? Because this comes up sometimes. So if I have 3/5 and divide it by 2, dividing by 2 is the same as multiplying by what? 1/2, okay? What is 3 over 1 times 5 over 2? 3 over 10. And then if I square that, what do I get? Remember, if you're squaring a fraction, you're just squaring the numerator and then squaring the denominator. Perfect. Perfect. Got it? So, do you feel comfortable completing the square now? Okay, then let's solve an equation by completing the square. It'll look something like this. Oh, let me write this. Completing the square. Solving square roots. Sorry about that. I forgot to put labels. That one just says solving with square roots. And then completing the square. Okay, so if we're solving by completing the square, your problem is going to look something like this. X squared minus 6x plus 4 equals 0. So if it's set up like that, probably the first thing at least I would want to do is try to factor it, right? Okay, so what multiplies to be 4 and adds to be negative 6? Nothing. Okay, so I could either like quit and cry, but I think my makeup looks pretty good today, so I don't want to mess it up. So I want to solve this using completing the square. So to complete the square, I want to get rid of the constants that's there because that's in my way. Okay, so I have x squared minus 6x equals negative 4. And I'm going to give myself some space because I need room to actually complete the square, right? What's going to go in that blank? So if I divide this by 2, I get negative 3, and negative 3 squared is positive 9. But if I add it on this side, I have to add it to the other side. Otherwise, I have completely changed the equation. I can add things to both sides of the equation and it keeps its value, right? But I can't just add it to one side of the equation. Okay? Now from here, I've completed the square, but I have to actually solve it now. So from the trinomial, what I want to do is take it to the binomial. Okay? So now I could think what multiplies to be 9 and adds to be negative 6. And the good part about this is it's the same thing, right? X minus 3 times x minus 3. So the other way I could write that is x minus 3 perfect squared. Well, that makes it nice because I already know how to solve problems like this, right? I just square root both sides. So I need to simplify the right-hand side, which gives me 5. Then I just square root both sides to solve for x. And I get x minus 3 equals what? Perfect. Plus or minus the square root of 5. And then add 3 to both sides to finish the solution. So x equals 3 plus or minus the square root of 5. Perfect. Now, are they all that easy? No, we know better than that, right? Okay. So what if it looked like this? 9x squared minus 6x minus 4 equals 0. Well, all these examples that I showed you before, what was true about the a value? It's 1. Okay? We don't want to complete the square unless that a value is 1. So how do I go about making the a value equal to 1? Every single thing, right? On both sides. Even though I know 0 is divided by 9 is still going to be 0, I'm still going to write it so that I know I did it. Okay? So that gives me x squared minus, so what does that simplify to? Perfect. Minus 4 over 9. Don't really simplify to anything, so we'll leave it 4 over 9. And now I complete the square. So now I add 4/9 to both sides to get that constant out of the way. And I have x squared minus 2/3 x equals 4 over 9. Now don't be afraid of this, okay? Because remember we said a minute ago, dividing by 2 is the same thing as multiplying by a half. Well, this gives me 4 over 6. Excuse me, 2 over 6. That's a 2. But that simplifies, right? To 1/3. Now if I have to square it to fill in to complete my square, what goes in that blank? 1 over 9, right? And if I add 1 over 9 here, I also add it on the other side of the equal sign. Okay? So now if I take my trinomial to my binomial, what is my binomial right here? It's either half of this or the square root of this, right? So what is it? 1/3. Yeah, absolutely. And it's minus 1/3, right? Because of the sign of that middle term. Equals, oh, that was so nice, 5 over 9. Now to solve, I do what I've done in the last couple of examples, take the square root of both sides. I have x minus 1/3 equals, this one's a little different because it's a fraction. For sure I'm going to get plus or minus, so I'll write that down. But when I take the square root of a fraction, you remember what I do? It's just like squaring a fraction like we talked about up here. I squared the numerator and, squared the numerator and squared the denominator. Do you know the square root of 5? Me neither. Over 3, right? But notice how careful I was to make sure that the square root only lies in the numerator. It doesn't go all the way down like we did right here. Okay? So now when I go to add 1/3 to both sides, I'm adding common denominators. So that's good. So I end up with either 1 plus or minus root 5 over 3, or depending on what the computer wants, okay, either one of those are the answer. They're both right. It just depends on what situation what situation they want to set up in for the answer. Okay? Any questions about completing the square? So I did a couple of examples where the leading coefficient is 1, and then I did an example where the leading coefficient was not 1. Okay? So the next objective is quadratic formula. And you know I love that. You know I love that quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. You remember that? You better, I'll kick you. Not really, because I don't want to lose my job. And I like these shoes. (8x squared plus 2x minus 1) First thing we're always going to try to do is factor. Okay? Multiplies to be negative 9 and adds to be positive 2. Yeah, I don't know either, right? Okay, so let's do quadratic formula then. We label our A, our B, and our C. Now I made you do that in Algebra 2. I'm not making you do that in college algebra because you're at least a year older now, right? Some of you 2 years older than I had you in class. And some of you can actually do this in your head now. Okay, you probably could do it in your head then, but we won't talk about that. Okay, so now I fill in my formula. X equals negative, or the opposite of B, so negative 2 plus or minus the square root of B squared minus 4 times A times C, all over 2A. Now it's just a matter of simplifying. Okay, again, some of you can do this in your head. Negative 4 times 8 times negative 1 is 32. So I have 4 and 32. So negative 2 plus or minus the square root of 36 over 16. Except we know the square root of 36. Negative 2 plus or minus 6 over 16. And then we can just do the simplification of these two fractions, right? Negative 2 plus 6 is 4. 4 divided by 16 is 1/4. Negative 2 minus 6 is negative 8 divided by 16 is negative 1/2. Okay. Now I've been quite remiss in all these examples that I've shown you so far. Are they all right? Is there a way you can tell that they're right? All of these answers, is there a way to tell that they are right? Always check them, right? Always plug them back in if you have a question whether it's right or not. Okay? You can always do that. Do I need to do any more examples for you of quadratic formula? Pretty comfortable with that? Okay, so our next objective is using the discriminant to determine the number and types of solutions. Do you remember what the discriminant is? Do you remember that it's part of the quadratic formula? It's b squared minus 4ac, right? It's the thing inside of the radical. This is the discriminant. Okay, that's the discriminant. By looking at the discriminant, by solving it, in this case our discriminant was 36, right? I could have told you right then we were going to get 2 real solutions because 36 is positive. When your discriminant is positive, I'll use a different color. When your discriminant is positive, you're going to get 2 real solutions. Okay, and what that actually looks like on the graph is something similar to this, where it crosses the x-axis 2 times. Now it might be upside down, right? It could be a parabola that opens upside down, but still it's going to cross the x-axis 2 times. 2 real solutions. In this case, it's crossing the x-axis at 1/4 and at negative 1/2. Okay. What happens if our discriminant is 0? Think about this for a second. If I have a 0 right here, I'm going to be taking the square root of 0, which is 0. So if I was doing this problem and this happened to be 0, I'd end up with negative 2 over 16. And that's it. Because I couldn't really plus 0 or minus 0. There's not a difference. So how many solutions would I have? So I would have 1 real solution. But according to the fundamental theorem of algebra, how many solutions are we supposed to have? 2 at most, right? And I said most of the time we're going to end up with 2. This is one of the cases where we end up with 1 solution, 1 real solution, but there's really 2. Because if I factored this, if this was factorable from the very beginning, and if this was 0, it would absolutely be factorable from the very beginning, it would look something like, if I was completing the square, it would look like this. Like x minus 1/3 squared. So in reality, how many solutions am I having? I'm having 2. They're just exactly the same. Okay? So while we say it's 1 real solution, it's really a double root. Okay? It's really called a double root. It's 2 solutions, but it's 1 because it's the same. Okay? And the graph looks like this. It's sitting on the graph, on the axis, excuse me, or it's hanging from the axis, but it only touches the axis once. So do you see why it's only one real solution? But do you see why we call it a double root? Yes? Okay. So positive and 0, what's the other option? So my discriminant could also be negative. If my discriminant is negative, how many solutions do I have? Still 2. Yeah. And that's kind of like what we talked about with complex numbers. Okay? So on the graph, it would look like this. Or like this. It literally does not cross the x-axis. That's why there are no real solutions. Sometimes we say no real solutions as opposed to 2 imaginary solutions based on what the problem is asking us. Okay? If it's saying how many solutions are there are 2 imaginary solutions. But if it says how many real solutions there are, then yes, the answer is 0 real solutions or no real solutions. Okay? Does that make sense as far as when it says use the discriminant to determine the number of type of solutions? Okay? One more. Determine the most efficient method to use when solving the quadratic equation. Well, what are the methods that we even talked about today? Factoring, completing the square, okay, square roots, these are the ones that we talked about today. Okay? Which one of, in your opinion, which one of these is the easiest? Completing the square? So for the record, that's a very rare answer. That's very rare for people to choose completing the square as the easiest. I like it the best because, like I said, I think it's a puzzle. Okay? Do you mind if we talk about square roots first? Because that's what most people think is easiest. Because what you end up with is something being squared equals a constant. Do you see why some people think it's the easiest? So when are you going to use square roots? When there's a square and not just an x, right? If there's an x in there, we probably don't want to use square roots. Okay? So we're going to use square roots when there's no x term. When we can just square root both sides and go on. Okay? Square root both sides. So when are we going to factor? So we first need it to be a trinomial always. So it's a trinomial, a binomial, or 4 terms, right? I think that has a name, but it's not important. And mostly we're going to factor it is, the time we're going to factor it is if it is factorable. If we recognize that it's the difference of squares, or the difference of cubes, or the sum of cubes, or if we recognize that there's something that multiplies to be the last and adds to be the middle, right? Or if we see that there's 4 terms, and if I factor something out of the first 2 and then the second 2, I'd still get a common factor of those parentheses. That's when I would factor it, if it's factorable. Okay? So when would I do completing the square then? Probably if my leading coefficient was 1. I can do it if my leading coefficient's not 1, but it's the easiest when leading coefficient is 1, right? And then probably when I can't factor it. If the leading coefficient's 1 and I can factor it, or I can't factor it, I probably do completing the square because it'll probably be pretty quick. Okay? So when will I use quadratic formula? When nothing else seems to work. Okay? Quadratic formula is always going to work. Okay? It's always going to work. It works every single time. It doesn't matter if you can factor it. It doesn't matter if the leading coefficient's 1 or not. It doesn't matter if there's an x term. It's always going to work. Okay? You can get super easy whole numbers. You can get integer answers. You can get real numbers. You can get imaginary numbers. You can get all those kind of answers from the quadratic formula. And you can get these answers from some of these up here, but it's not always necessarily the easiest. Okay? So does that help you, just in the conversation we had, determining the most efficient method to use when solving a quadratic equation? Okay? Is there always a most efficient method? No, there's not. Sometimes you're going to do quadratic formula because you remember the song. Sometimes you're going to do completing the square because you feel like it today. Okay? There's typically not a wrong way to solve a quadratic. There's sometimes an easier way to solve it. Okay? Any questions on any of these objectives for today? You good? All right.